I'm looking for the area of the shaded region. So, okay, there's my proportion. 140 over 360 equals x over 64 pi. Now, where did you get 64 pi from? What's this?
The whole what's the name? Area of the circle.
The area of the whole circle, yeah, because the area is pi r squared. So the area of this circle is pi times 8 squared, which is 64 pi. So we have the area of the whole circle. All right, now I can solve this proportion. Pretty simple. We know how to do that. Cross multiply, and I get 360x is equal to, what's 140 times 64?
8,960
8,960 what?
pi.
Pi. Now I have to divide both sides by 360. What do you get?
24.8,009.
24.89
It's a lot of eights.
pi. I'm rounding it up. Okay, but look at your answer choices. Which answer choice is tempting right now? Which one looks like it's going to be right?
25.
Yeah, it looks like 25 is going to be right, but that's 25 square units. But we have 25 pi square units. So we got to do a little multiplication. So what do we get? Remember that pi, we memorized it, but you can basically use 3.14. You can use your calculators. So it's 24.89 times 3.14.
78.90.
78.90. I got 0.15. 78.15.
Wait, what?
Try it again. 24.89 times 3.14. Yeah, 78.15. So answer choice C. So the only difference in this one is that the final answer, they actually used pi. We're in our use, like usually we're pretty used to just keeping it with the pi there, but sometimes you actually have to multiply times pi and get your final answers. Any questions? Okay. Do you like what? Your profile pic? I haven't seen it yet. Hold on. Oh wow, that is not what I expected. That's very cute. All right. So any questions? Any questions at all on this problem?
I'm good.
Hi, Daniel.
Hi, hello, hi.
All righty, guys, let's go ahead and get started. So we kind of are covering a lot of different things today. We're probably not going to get through all of it. If you guys look over here, there's like 31 slides on this presentation. We're not going to get through all of it, but I want to get as far as we can. Starting with the circle similarity theorem. All circles are similar. Why do you guys think that?
Yes, that is true.
Why do we think that's true?
Because they are all round. They all have radiuses. They all have diameter. They all have circumference, and they all roll.
Yeah, so they all kind of have the same characteristics, right? And let's just think
Yeah,
about
they
really
just had
quick.
different sizes and lengths and stuff.
Okay, so they're just different sizes, and that's really important because which transformation, what type of transformation can make something similar? Good. Perla's got us. Dilations. Dilations create
Oh God, are we gonna be dilating circles today?
similar figures. Not really. But even
Oh,
if we were,
good,
that
good. I
wouldn't
don't
be
want
that.
to dilate circles.
Even if we were, that wouldn't be
That
that
would be
hard.
pain.
Dilations
That would be
create
pain.
similar figures. So we can basically take
It
any
actually would
circle,
be pain.
Daniel, you can take any circle in the world and dilate it to create another circle. And so that's why all circles, every circle ever, is similar to each other. So let's just take one example like this one, and let's think about what transformations would be needed to map circle C onto circle D. Just looking at this
So you would
example.
dilate circle C by like 2, factor of 2, and then you would move it on to circle D. Or you could just dilate it on a certain point on the graph where the circle D is.
So I'm hearing dilation, and then you said that you can move it. Now, what do we call it when we're moving it?
Transformation.
Not
Wait,
transformation. It also starts with
translation.
translation. Good.
Yeah, yeah.
So we're going
I
to
know what I'm
dilate it,
saying,
and
right?
then we're going to be able to translate it as well. So I kind of drew a circle on top of it. So this is circle
I'm gonna
C.
walk around now.
And I'm just going to translate it. And now when I translate it, what matches?
The center.
The center matches.
The center, the place where it is.
The center, yeah. The center matches. And then from there, I can dilate it, keeping the same center until I've got the same circle. So that's why,
Until it
it's pretty simple to
be.
think about it, but that's why all circles are similar because you can get from one circle to the other by translating it so that the center matches. And then once the center matches, you just dilate it till the whole circle matches.
You can make an unlimited amount of circles out of one circle.
You sure can. Okay, so let me bring this guy back
Tons
over
of
here.
different sizes.
Now, Daniel said something about a scale factor. And we don't have any units. There's no units here. But generally, in general, who can remember,
Can't you use like the radius?
Yeah. How do
To
we usually do our scale factor? Is it image
you
over
find the
pre-image
length
or
of like one
pre-image?
side or a point, and then you divide it and multiply it to see the
Good.
dilation factor.
Good. So, and it's
It's usually
usually
divide though.
divided, and it's usually going to be image over pre-image. So if circle C is my pre-image and circle D is my image, using the radii, what would be my scale factor?
The whole number that is made. Oh, it doesn't have to be a whole number. It can
Yeah,
be
use the
the number
letters.
that is made from simplifying the fraction
And
or
what
making
two
it into a
numbers,
number.
which two variables are going to go in using the radius?
Variables, the radius of the pre-image. Is it radius? Right, it's radius or diameter.
What are they showing us on the screen? Is this the radius or is this the diameter?
Diameter? Radius? Wait, radius. Right?
This is the radius, yeah. So if I'm doing image over pre-image, the scale factor is just going to be R over
Radius and
S.
radius.
Yeah. So whatever the radius measures, we can divide them and get our scale factor. So it's pretty simple. Do I have any questions on that?
Nope.
All right, so now let's do an example. So here are my two circles. I have a large circle and a small circle. And let's go ahead and just try and answer all of these questions. So anybody can answer at any point. I just want to hear from everybody, participation. What is the radius of the smaller
The
circle?
radius of the small circle is 2.
Easy, 2.
The radius of the larger circle is 6. The circumference, I don't know.
Careful. Pause
Um,
there. Pause, pause, pause. 6 is just this part. Just that part. So the whole radius would be, I think Tyrone just said it, and Jalen.
8.
It would be 8. Okay, because we know that the other part of it is also 2. So the whole thing has to be 8.
Oh.
Okay, now let's go ahead and do the circumferences. What would be the circumference of the smaller circle?
I'm gonna let you guys figure that out.
What would be the circumference of the smaller circle? Good, Jalen. 4 pi. Because remember, circumference is 2 pi times the radius. So the circumference is going to be 2 pi times 2. So circumference is 4 pi. Questions on circumference for the smaller circle? Okay, so then what's the circumference of the larger circle? 16 pi. Because again, you just multiply it times 2. I'm actually going to write this formula over here just so we remember it in general. The circumference is 2 pi times the radius. All right, what about area? Area of the smaller. It's also 4 pi. Now, what's the formula again for area? Pi r squared. Good. Pi r squared. So for the small circle, the area is the same as the circumference. But what about for the larger circle?
I don't know.
Pi r squared. The radius is 8. What's pi times 8 squared? What's 8 squared?
8 squared.
It's 64. So my area is 64 pi. Okay, so I've got both of the radii, I've got both of the circumferences, and I've got both of the areas. Now I want to see what the scale factor is for each of these. For the radius of these two circles, what's the scale factor? What's the scale factor?
4.
You said 4?
Yeah, 4.
Good.
It's 4 for the radius, 4 for the circumference, and for the area. I don't know.
It's 16 for the area.
For the area, it's 16. Good. Because 64 divided by 4 is 16. So what's the pattern? What do you guys notice?
4 times 4 equals
So the
16.
first two are 4.
So for the radius and circumference, scale factor is the same. But when we're talking about area, the scale factor is going to be that number to the power of 2. To the power of 2. So the scale factor ends up being 16. So that's kind of the pattern. So scale factor for radius, so radii and circumference the scale factor is, we can just call it K. Here, let me write this in a nicer way. So for radii and circumference, we have K. But for area, we have K squared. Does anyone have any questions on that? And Perla, I don't know. I really don't know. Maybe I'll come back to Miami. I would love to come back here. It's nice here. I like the warmth. But maybe
Wait,
I'll
you're
end
not
up in
in
New
Miami
York.
right now?
No, I am. I'm just saying after I become a doctor, because I'm not gonna go to medical school here. I'll probably be going to medical school in like Philadelphia
Oh.
or Boston or somewhere.
Wait, but how does math incorporate medical school?
It doesn't. No, there's a
Why
little
are you
bit.
taking medical school? You
There's
should
a little
like
bit of
take.
math.
You should go to something where's your strong suit, so you're successful in that business.
And who says that I'm not good at science and medicine? I can do more than one thing. I'm actually better at science and medicine than I am at math. So.
Wait, what? Oh.
It's true. It's very,
You've
very
been
true.
algebra teacher and a geometry teacher. You've probably been more types of math teacher. You have tons of experience in math. Why don't you take like a college or like university
Because
teacher?
I like math, but it's not like I don't feel like I can use math to help people, and I want to help
Yes, you
people.
can. Maybe you could be like a rocket scientist or something. We have to do a bunch of
Yeah,
math and
but
calculus.
it's just not. It's not the way that I want to help people. Does that make sense?
It kind of involves science since
It does.
science and math are two of your strong suits. So
It does, but physics is. I don't like physics as far as science goes. I prefer biology, and I really like chemistry actually. But more than anything, I want to be a doctor because I think it's a really like the whole job of being a doctor involves solving problems. So if you think about it, like that's kind of what math does too, right? You're solving problems in math and you kind of use that same part of your brain as a doctor because you see lots of patients with a lot of different illnesses and problems that they don't know how to solve. And you kind of have to figure it out for them. So it's still using that same part of my brain, just not in the same way. So anyways, ooh, that's always a fun unit. All right, any questions on this page though? Any questions? So radii and circumference, they get the same scale factor, but for area, you have to remember to square the scale factor. So here we go. Here's a couple of more challenging problems. Can I have a volunteer read this one, please?
I will.
Go ahead.
Wow.
The drawing, Tyrone. The drawing below shows circle B and circle E. The measure of arc AC equals the measure of arc DF, and the length of arc AC is 3 times the length of arc DF. Which equation best describes the relationship between line segment? Is that line or line segment?
Line segment.
Oh, line segment BC and line segment EF.
Awesome.
Well,
All
this
right.
is why you're not my friend. You always stealing my spotlight.
Oh, you can get the next one, Tyrone. Good friends are gonna like cheer each other on, and if you are a good friend, you want your friend to have the spotlight. I'm
No.
just saying. Oh, then maybe you're the one who's not a good friend. Okay. So anyways, they're telling us that AC is equal to, the measure of arc AC is equal to the measure of arc DF. So they're basically telling us that these two angles are congruent. And then it's telling us that the length of AC is 3 times the length of DF. So if DF is X, what would AC be? If DF if I call it x, what would AC be?
3x.
3x. Right? So this thing is 3 times the length of that one. Then it's asking us which equation best describes the relationship between BC, so this over here, and EF. Okay, so let's think about it, because an arc is a part of what? Is a portion of the what?
Sector? No. Circumference.
Of the circumference. Right? An arc is like the crust of a slice of pizza, but the crust of a slice of pizza would be part of the crust of the whole pizza. So an arc is just a portion of the whole circumference. So what do you guys think, what is going to be the scale factor? Is it k or would it be k squared? Or okay, so Rio says the scale factor is 3. Good. The scale factor is 3. If the scale factor is 3 for the circumference, what would be the scale factor for the radius?
Radius 3.
Yeah, also 3.
Because they're both the same. The
Yeah,
only thing that's
because-
different is the I forgot the last thing.
Which one's different?
That means 3 times 3 is 9.
Hold on. Which thing is different? So circumference and radius get the same scale factor. In which situation would the scale factor be different? This goes for anyone.
Mm,
If the circumference and the radius get the same scale factor,
the area is the different one.
the area is the different one. But what are they asking about in the answer choices?
Mm. Oh, those are the radii, right?
Those are
They're
the
both
radii.
radii.
Yeah. So now take a look at the possibilities. Which one, if the radius EF, if I call that Y, what would be BC?
3y.
3Y. Yeah. The scale factor is the same. All right, because on the one hand, I'm talking about circumference. On the other hand, I'm talking about radius. So they're going to have the same scale factor. So answer choice?
B.
B. Exactly.
Miss Lopez, I kicked Daniel out of Zoom. I think it's the Wi-Fi.
Oh, okay. I'll wait for him to be able to come back.
Okay, he's joining.
Hello, I am back. Zoom
Oh,
is
okay, good.
trash, and so is my computer.
That's okay. That's okay. We gotta just be patient. And then Jalen was asking about the area. Yes. So in this case, the question isn't asking about the area, but if you wanted to find the area, the scale factor would be 9, not 3. Good, good, good thing to point out. Any questions on that? All right, let's try another one. Now, no pictures, so read this one carefully. Read it very carefully. I just want to see how we do on a poll. Now, I know we just learned about this, but read it carefully and see if you can figure this one out. All right, I see 5 out of 6 of you have voted, so I'm waiting on that last person, but take like 10 more seconds. All right, cool. Everybody has put in their votes. So here are the results. This is exactly what I thought would happen. So
No.
most people chose D, but it was kind of between B and D. So let's take a look.
Probably D.
Probably D. Which statement correctly relates? Okay. So if the scale factor for the radius is 5/2, what did they do here to get 125/8? What did they do there? Think about it. Not scale factor of 3, Jalen, but you're really close. What they did was they did 5/2 to the power of 3. Cubed, yeah. Which is not the right relationship. B. Would the area be the same as the scale factor for the radius? No, it would not. It would not be the same. C, 3/2 and 3, what they did here is they did 3/2 times 3. Or no, times 2, I mean, times 2. Which gives you 3. But that's not what you're supposed to do. What are you supposed to do?
Dang it, it's D.
You're supposed to put it to the power of 2. So when I raise that to the power of 2, I get 9/4.
Oh.
All right, so one more time, just to make sure we understand.
So we multiply the denominator by the power of 2.
Both the numerator and the denominator, yes.
Denominator.
Okay, so the scale factor for the area is k to the power of 2. Make sense? Any last questions on that? Because now we're going to move on to something else. Like I said, today is kind of a lot of different things smushed together. So any questions on what the whole scale factor situation? Okay. All right. Now, this is kind of like what we did in the bell ringer. So let's just do this one together. We're going to find the length of AB, and we're going to express the answer in terms of pi. So we're not going to calculate, we're not going to multiply times pi, we're just going to leave it as pi. Find the length of AB. So I need to set up a proportion. What should I do?
I think first we should like maybe like draw a line, like connect the radii to the center to like get our little section.
Okay.
Well, Jalen stole my next like step, but okay.
Okay, so he's got this part, 60/360. And then I'm finding the length. So be careful with what you choose for the other side.
Well, can't we do like, oh wait, never mind. I was about to say the circumference.
Okay, so that's my question. Are we looking for circumference or are we looking for area?
Who's Renee?
Circumference, because it's the arc length, not the sector area.
Good. Since we're looking for arc length, that's part of the circumference. So Rios, you had the area formula, but we are looking for the circumference formula. So 2 pi r. So what is the circumference of the circle?
18 pi.
18 pi. Make sense? Makes sense. Okay, cool. But what I'm going to do is I'm actually going to write this the following way. I'm going to keep R where it is. And actually, you know what? No, I'm not going to do that. I'm going to do it the way we usually do it. So this is 18 pi. And what do I do now?
Cross multiply.
Cross multiply. What do we get?
360x equals 1085.
1000, so 1085.
80.
Wait, 1805?
No, 1080.
Oh, 1080.
Miss,
I'm going off of you. I'm not using my calculator.
what? I said 1080.
I heard
Perla OD typing in the
1085.
wrong
Oh,
way.
that's
108080808.
because you said 1080 pi. I thought you were saying 1085.
Yeah.
Mm-hmm.
Okay,
Miss,
okay.
360x, not 360 pi.
Oh my goodness. I just keep messing it up. Okay,
Miss, these kids have got into your head.
I know. All right, now what do I do?
You did.
Now what?
Divide by 360.
Divide by 360. And we get x equals
Negative 1000
3 pi.
3 pi.
equals negative 1 over x equals negative 1 equals
3 pi.
negative whatever
Okay.
the
Daniel, mute yourself. Okay, so here's my final answer. Now I'm going to go back and I'm going to do this a slightly different way. But we already know what the answer is supposed to look like, and I'm not going to move this. I'm not going to make it go away. I'm just going to leave it off to the side. Because I'm going to do this a slightly different way. What I'm going to do is I'm going to write the formula, and I'm not going to fill in any of the blanks yet. Okay? So the 60 degrees, we're going to call that M, and you'll see why in a moment. So whatever that angle is measurement, like on any circle, in this case, it's 60 degrees, but on any circle, we're just going to call it M for now. And rather than writing the actual circumference, I'm just going to write the formula for circumference, 2 pi r. Now I'm solving for x, right? I'm solving for x. So I'm still going to cross multiply. I'm not filling in any of my values yet. But I would get, I'm going to do it this way, 360x equals 2 times pi times r times m, right? And then, or actually I'm going to put m on the other side. So it's m times 2 times pi times r. And then what would I have to do to both sides again?
Divide by 360.
Yep, we would still be dividing by 360.
Wait, miss, what does the M represent? Oh, the measure of the
The
arc.
measure of the angle, yeah, or the arc. So here's my formula. So I end up with this kind of, it kind of looks a little challenging, but let's just see what this formula has. So in that formula, I have m over 360 times 2 pi r. So where did we see m over 360 before? I'm gonna.
The first time we did it, we did 60 over 360.
And if you look, I have it over here as well. That's m over 360. And then 2 pi r was where?
Across from it, like on the other side, the opposite side. I
Down
don't know well.
down here. So rather than take this long, I kind of did more work than I had to, because what's something that I can do instead? Oops. to go from that to this? What did I basically do to both sides? Daniel, Rios, I can tell you're not paying
Oh.
attention.
Multiply by 2 pi r.
Yeah.
Oh, isn't that what we did with the sine, cosine, and tangent? That
Similar, yeah. It's very similar, yeah. So basically what happens is you can just multiply times 2 pi r on both sides. And we end up with this neat little formula right here, which can allow us to find the length of that arc. So I'm going to use this formula, but I'm just going to plug everything in now. So x equals 60 over 360 times 2 times pi times the radius, which is 9. And basically what I'm doing is instead of plugging it in to begin with and then doing the whole thing and finding my answer, now I just have a formula. I can plug everything in all in once, plug it all into my calculator and get my answer that way. And you should come out with the same answer. So in your calculators, you can do 60 divided by 360, get that number times 2, and get that number times 9. What do we get? So 60 divided by 360, multiply it times 2, multiply it times 9. What do you get? Anyone? This is simple,
I got
simple.
the same thing.
In our calculator, yeah, you still get 3 pi. And Rios, if you do that into your calculator, you should also get 3. So 0.16666666 times 18 gives you 3. So what we did is we just derived, the word derive just means that we were able to create the formula that gets us the arc length. So I'm going to go ahead and switch over to this slide. Here's the same formula, which we just found. We just figured this out. And I want you guys to write it down. And if you want to write it down this way, we can do it this way. So S equals M over 360 times 2 pi r. And we're just going to label each part of it. So S is the arc length. M is what?
The arc, like the angle measure of the arc.
Yeah, so it's kind
What
of
is that called?
it's kind of hard to like remember the difference. One S is the whole length. Like if I took a measuring tape and I tried to measure the length, that would be S. M is the degrees. So that's if I took a compass or a protractor and I tried to find the degrees of the arc. So I like to call M, because remember the arc is the same as the central angle. So we can just say it's the measure of the central angle. And then of course R is pi, is the radius. So we have a little formula, which is nice because sometimes when you have a proportion, it takes a little bit longer. But with the formula, you can just plug everything boom, 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 boom into your calculator, and then you're done. Should we memorize this? Yes and no. So first of all, if you like using proportions instead, then I'm not going to tell you to use this formula, because if the proportion works for you, then you should keep doing it with the proportion, right? Like if that strategy is a good strategy for you, then I'm not going to tell you to do something else. Some people prefer to use the formula instead. So if you prefer using the formula, then do that. It really depends on your preferences. Now, another way to memorize this, I can simplify it a little bit, because what is 2 pi r? What is 2 pi r? When I say 2 pi r, that's the what? The circumference. So another way to memorize this is to just remember m over 360 times the circumference. Any questions on that? All right, so let's do a couple practice problems. We've done very similar problems before. It's just that instead of using proportions, we're going to use the formula instead. Just to see if you prefer it. If you prefer doing it this way, then continue doing it this way. If you prefer using the proportions, then you can learn how to do it this way and then go back to using proportions. So, Tyrone, I promised you could read. Go ahead.
Yay. On a clock face, the minute hand of a clock is 10 inches long. To the nearest tenth of an inch, how far does the tip of the minute hand travel as the time progresses from 12 o'clock to 12:15?
Awesome. So from 12 o'clock to 12:15, where is 12:15? We know how to read clocks, right?
No,
Oh, come on, where's the 15?
3.
at the 3.
Sometimes I'm really shocked. Like some kids, maybe a little bit younger than you guys, since they're so used to using like digital clocks, like they're on your phone, they don't know how to read clocks. It's crazy. All right, so it's at the 15, and we're looking for the distance that the hand travels. So I'm looking for the length of that arc, S. What's the degree going to be? What is the central angle going to be at this point?
90?
Good, 90 degrees.
9,000.
90 degrees. And we said that the length of the minute hand is 10 inches. So now I can fill in all of the blanks into my formula. So the length is going to be 90 over 360 times 2 times pi times the radius, and the radius is 10.
Are we going to leave it in terms of pi? Or are we going to like use 3.14?
Let's see, it doesn't specify in this case. Let's simplify it. Let's multiply times pi at the end.
Oh, okay.
Okay, because it's in inches, so I want to know how many inches it's going to be. So go ahead, plug all those numbers into your calculator. 90 divided by 360 times 20. What do
You
we
can
get?
hear me typing.
All right, so 15.7, that's your final answer, right? Okay, so before you got that answer, what did you get when it was in terms of pi?
Wait.
Go back.
Five pi.
We got 5 pi.
Yeah.
Good. And then the final answer, once you actually multiply, so 5 times 3.14, that's how you got 15.7 inches. That's our answer. So what do you guys think? What are the benefits of the formula rather than using a proportion? What do you guys like better compared to using a proportion? So Perla likes the formula better because all you do is plug things in. And Jalen likes the proportions. So you can use whichever strategy you prefer, but I definitely just like to make sure that everybody knows how to do both. And then from there, you can choose which one you want. He likes portions of food. All right, questions on this problem? All right, let's do another one. Oh, let's do another 3. Forgot I put this many. Okay, so I'm gonna rewrite the formula up here. And again, it's up to you if you wanna memorize it, but if you do memorize it, it'll make your life easier. So go ahead and actually let's do number 5 together, and then I'll have you guys do number 6 together and number 7 on your own, I mean. So what's M for number 5? What do I plug in for M? Jalen, Rios, cut it out. Focus on my problem. What do I plug in for M?
90.
90 over 360 times 2 times pi times what?
20.
20. And give me your answers in terms of pi. So we'll keep these in terms of pi. Go ahead. All right, what do we get? 90 over 360 times 40. Good, Rios. Got 10 pi. So now go ahead, do number 6 and do number 7. Take about 1 more minute. And round it like it says, round it to the nearest tenth. All right. I got answers from Rios. I got answers from Perla. I haven't heard from anybody else. Send me your answers in the chat, please. All right, nobody else has any clue? Okay, I got an answer from Jalen. I haven't heard from Emily. I haven't heard from Samaj. I haven't heard from Tyrone. I haven't heard from Daniel. That's a big problem. Tyrone, I'm waiting on you. Daniel, I'm waiting on you. All of your classmates are waiting. I'm giving you guys 3 seconds. If you don't get it, 10 seconds. If you don't get it in 10 seconds, I'm calling on both of you to answer the problem for us. Because clearly I got to teach it again.
120 over 3 6. Wait, I have to type in the chat, right?
You can say it out loud. Keep going.
120 over 360 multiplied by 2 pi multiplied by 3.
Good.
Haha.
It's not that hard. The reason I'm making you do it out loud now is because this wasn't that hard, and I shouldn't have to beg for your answers. See, it's because Daniel was typing out that whole thing instead of doing his work. Now I can take a screenshot of that and send it to your mom so she can see what you've been doing instead of doing your work during class.
But I answered the question, didn't I?
After 5 minutes, which is not acceptable. 120 divided by 360 times 6, you get 2 pi for number 6. 2 pi. Questions on number 6, because I know a couple of you got different answers. So do I have any questions?
So there's an easier way to do that. You can just multiply the 3 by the 120 over 360 to get a 1 instead of having to do all that math.
Well, there you go.
Then
If you
1
can find
times
a
2 pi is 2
shortcut,
pi.
if you can get a shortcut, go for it. That's good. Next one, 67 over 360. This one's not quite as simple, right? Because this one, 3 times 120, you can do that in your head a little more easily. But here we got different numbers. 67 times 360 over 360 times 2 pi times what?
So 670 over 360 multiplied by 2 pi.
Is it multiplied by 2 times pi times 10 though?
Yeah, but we don't really want to multiply 20 pi.
Hold,
So I think it would be easier if we multiplied it to the fraction than.
okay, pause there, Daniel. What's the radius of this circle?
No, 5?
It's 5, not 10. This is showing you the whole diameter. That was the trick with this one.
Oh.
So now using these numbers, like you were saying, 670 over 360, you can use a calculator.
So
What do we got?
335
Who
over
can
360.
share the final answer?
Oh, final answer.
So Tyrone, what you got times 10, what do you get? 1.86. To the nearest tenth,
Nearest 10th.
what would that be?
19.
1.9.
19.
1.9.
10, 9. 11.
1.9. All right, it shouldn't be like that, y'all. That should not have taken as long as it did. If I'm asking you to send me answers in the chat, I'm asking you to send me answers in the chat. I'm not asking you to wait around for me to give away the answers. So I'm talking specifically to Daniel and Tyrone right now.
Me.
Everybody else sent them in without a problem. Next question. Okay, now we're doing area. So we just did a lot of sectors, sector length. Now we're doing area. But we're going to do a very similar thing. So with this question, let's start by doing it as a proportion, and then we'll switch over and turn it into a formula. So as a proportion, what would I write? Using a proportion. How do I set this up? 120 over 360 equals
So 120 over 360. Like, oh, we're another fraction?
this time we're using our proportion.
Okay, so
X
12
over
over 36, which can then be simplified to 6 over.
Hold on, we're not there yet, Daniel. We're not there yet. We're still filling in our blanks because I'm still missing what is the area of the whole circle. It's pi r squared. So Rios, you got the circumference this time. I need you to find the area. There we go, 225 pi. Okay, because the radius is 15. 15 to the power of 2 is 225. Okay, well, I could do it this way with my proportion. We cross multiply. I use my calculator. 120 times 225 gives me 27,000 pi. And then 360x. And then I would divide both sides by 360. And I would get x equals 75 pi. 75 pi. So we already know how to do this. We've been doing it for a couple of weeks now. So this is using proportion. But just like the previous problem, we're going to turn this into a formula. What calculator do I use? Just a calculator, why? I'm not proud of my answer to that question. Yeah, I had a calculator, but I think I left it at school at one point and I really don't know where it went, so I don't have mine at home with me. I lost it. I think it's probably in my desk, honestly. I think it's probably in my teacher desk somewhere. But anyway, any questions on how I got my answer for area? Okay, that's proportions. Now let's make it into an equation and into a formula instead. So here's my, come on now. Here's my proportion. I'm gonna move it over. And I'm gonna set it up the same way. So my angle is M. So very similar. M over 360 is equal to X over the area, and the formula for area is pi r squared. Then I can cross multiply. Or rather, what should I do to both sides to get x by itself? Times pi r squared. On both sides. So it cancels out. And I'm left with x equals m over 360 times pi r squared.
Wait a second, but if we already have x from the last equation, can't we plug that in to make this easier?
Yes, but what I'm doing isn't, I don't want to know the answer. I'm just transforming the proportion into a formula, because now this is a formula. In
Oh,
fact, this is my area formula. Area of a sector.
so M is the what is it again called again? The angle, the central angle,
Mm-hmm.
and then 15 is
So any questions on how I got the formula?
no, I understand.
Cool. So now I'm going to use it to solve a couple problems. So here's my formula. I'm going to write it down over here. Area m over 360 times pi r squared. A stands for area of a sector. M is, like Daniel said, M is the central angle. R is the radius, but importantly, this whole thing right here is the area of what? That whole pi r squared would be the area of the whole circle. So similar to what we were doing before, this equation helps us to find the area of the sector. And they're very similar equations, aren't they? What's the only difference between this formula and the one we were using before? This one uses the area over here, and the other one uses the circumference in this portion right here. So this is basically the same. So if you're trying to memorize both of them, it's going to be pretty easy to remember, because the only thing that changes is that we use the area formula on one of them and we use the circumference formula on the other. So let's go ahead and plug things in. Let's do this one together. What do I plug in for M?
131.
131. So 131 over 360 times pi.
Are we going to use like pi or?
Keep it in terms of pi.
Okay.
And what would be the radius squared?
144.
144. Go ahead, plug things in. You can use a calculator. Let's get our answer. Nice. And so Alejandro got 52.39 and Perla got 0.4. So let's talk about why you might have gotten a different answer. But in general, when you're solving something like this, when you do 131 divided by 360, see how I get this really long number? Right? I don't want to erase that. I want to leave it where it is. Don't rewrite it. Just leave it where it is. Just multiply that times 144. So who's actually closer? It's okay, Rios. It's okay. So actually, Perla got the more correct answer, 52.4 pi. 52.4 is what we should get. Did anyone get something different and they're not sure why? Or would anyone like to try it? I don't know. Does anyone have any comments or questions? All right. So do these couple ones on your own. We got through pretty far, you guys. I think we're going to stop here. But go ahead and do these on your own. Take a moment. And then we'll come back and do them together. And then I think we'll be done for today. Oh, God. Focus on your math, y'all. Focus on your math. I don't want to be liable for something here.
That's funny.
Jesus.
Miss, what does it mean as a multiple of pi?
In terms of pi.
Oh. They always have to overcomplicate everything.
Take another minute or so. All right. Send me your answers in the chat, please. I see one answer in the chat. I think I got 2 answers in the chat. Did someone else send me one? No. So Perla's the only one who understands this? Is that what's happening? Perla and Emily, they're the only ones. Nobody else understands. Because I'm pretty sure I asked at this point, I was like, oh, does anyone have any questions? And I didn't get any questions. So that means that everybody should have understood it at that point. But if I'm not getting responses in the chat, then what does that mean? Put yourself in my shoes. If you were the teacher, what would you be
How do I
thinking
type
right
the
now?
pi symbol?
Just say pi. Just write pi.
Okay.
Y'all, I'm tired. I'm tired of this. All right. M over 360. What's my measure of M? 180. How do you know?
Because well, at first I was kind of confused. I was like, "What is M?" But then I realized it shaded half of it.
So it's semicircle. So it's half of
yeah.
the circle. So it's 180. So 180 over 360 times pi. What's R?
0.8.
0.8. Because the whole thing is 1.6. So the radius is 0.8. Exactly. So 0.8 to the power of 2.
Oh, 0.8. I put 8.
Yeah, there's a decimal there. So what do we get? This is 0.64. So 180 over 360 times 0.64 pi. What do we get?
0.32 pi.
0.32 pi. All right, to the nearest hundredth, so we're good. Second one, what's my M? What's the angle?
22.5.
22.5 over 360 times pi times, is it 24 or something else?
24.
It is 24 in this case. So you always want to be very careful. Just make sure you're putting in the radius and not the diameter by accident.
Yeah, I got one right, and I got the second one wrong. I got the first one wrong because I didn't put it as a decimal.
Ah, okay. So what do we get in the end? When you put everything in, you should get 36 pi. Did anyone get something different than 36 and would like me to show you how we got to that answer? All right. I have one quick question. I think I think this is the only one that I can do because the rest of them go a little further. One very easy, quick question. This is taken from an old test, believe it or not. Go ahead, put in the answer. Take 30 more seconds. This should not take very long. I see 5 people have answered. That's almost everyone. All right, 5, 4, 3, 2, 1. 7 out of 7, 100% got it correct. It is answer choice D. So even if you prefer to use proportions, which is fine. I know a couple people prefer the proportions. Just make sure you know the formula. Just make sure you know the formula because this was literally from a past test. And you guys know that those questions, they often come back. So if you can just memorize the formula, you could get, this is a free A, easy A on the test. Make sense? Okie dokes. I'm looking now, I just want to make sure that there might be another one. Ooh, there's one more question, hold on. Give me 1 second and let me show you the last question I want to do. I didn't put it on this PowerPoint, so I'm sharing it from my computer really quickly. But it's very similar. Oh, hold on, not that one. Okay, so take a look at this one. Past test. So again, always good to to know what it looks like on a test. Let me go ahead and put up a poll.
Wait, Miss, can you scroll up a little so that like the 1.7 is at the top?
Like that.
Okay, wait. Yeah, there you go. Thank you.
You're welcome. So to derive something just means to rearrange one formula to turn it into something else. Oh, you know, actually, everyone who put the answer so far has gotten it right, but I just realized that this goes ahead. I just realized that this actually includes something that you're learning tomorrow. So if you're a little confused by it, that's okay. I'm gonna end it though. The answer was, ooh, a couple people just put in, okay. The answer was B, which most people got, but I just noticed that it actually, this question goes a little bit beyond what you guys know right now. There's something else in here that we haven't talked about yet, but we'll get to that tomorrow. So tomorrow, another lesson, very similar. Well, it kind of goes, we're going to continue with what we learned today. And from there, we have one more thing that I'm going to teach you guys on Friday, Monday of next week, and Tuesday of next week, we are reviewing. And then what's on Wednesday of next week? Oof, y'all have lots of testing. I know. You have our test right after that. And I'm sorry that it has to be that way. I would just rather do the test before spring break than have you take it after spring break, because spring break, I don't want you guys to be stressing. So at least you'll do 1, 2, 3, you'll be done, and then you can relax hopefully a little bit. All right. So that's all for today, guys. Have a good afternoon. I will
Bye,
see you
Miss.
all tomorrow.
Beep.
Bye, everyone.
Bye.
Hi, Miss.
Bye.